Hello. For our project, we decided to investigate Newton's laws of motion in the context of a basketball shot and to determine the force required to shoot a basketball from different distances. For the first part of the experiment, a shot was taken on the free throw line. During flight, the basketball is in projectile motion and the only forces acting on the ball is gravity. In projectile motion, there is the influence of air resistance, but in this case, air resistance is negligible. The distance measurements for the flight of the ball are shown. The height of a standard basketball hoop was 3.05 meters, the distance of the free throw line was 4.57 meters, and the height of the release point of the ball was 1.91 meters. Using the distance measurements, we are able to use kinematic equations to calculate the initial velocities in the horizontal x direction and vertical y direction. With these calculations, we are able to calculate the initial diagonal velocity and the angle of the shot. For the second part of the experiment, a shot was taken from the three-point line. The distance for the shot increased to 6.1 meters. For part 2 of the experiment, the same kinematic equations were used to determine the x velocity and the y velocity. With the new distance, the initial diagonal velocity was calculated to be 13.56 meters per second, and the angle of the shot was 20.39 degrees. To determine the force required for each shot, a logger probe video analysis was used to determine the acceleration of the very beginning moments of each shot. According to Newton's second law, acceleration is directly proportional to the force and inversely proportional to the mass. By rearranging the equation, we can calculate force as the product of mass and acceleration. With the weight of the ball being constant across each part, the only element that has changed is acceleration. The force required for shooting a basketball from the free throw line was calculated to be 13.98 newtons. For part 2, the force required for shooting a basketball from the three-point line was calculated to be 18.25 newtons. With the results calculated, there is a clear trend of increasing force as distance increases. Thank you for watching.